Now we are going to see expansion in liquids and gases. Already in 9th standard in your lower classes you have studied about the expansion of solids, liquids and gases. For a given rise in temperature, a liquid will have more expansion than a solid, and a gas substance has a highest expansion when compared with other two, solid and solid and gases. How come you know the liquid expansion? Coefficient of cubical expansion is independent of temperature, whereas its value of gas depends on the temperature of gas. Real expansion and apparent expansion. Real expansion. If the liquid is heated without any container, it's not possible, then the expansion that you observe is termed as real expansion of the liquid. That means if you are heating a liquid in a container, you must subtract the container expansion from the expansion of the full expansion. Then only you will be getting the expansion of liquid separately. That is called as your real expansion. Coefficient of real expansion is defined as the ratio of true rise in volume of the liquid per degree rise in temperature. Whatever be the expansion, the definition will be same. Rise in length or volume or anything else to the original value per degree rise in temperature. Expanded volume to the original volume for a degree rise in temperature is called as your expansion. Apparent expansion of a liquid is defined as the ratio of apparent expansion rise in the volume of the liquid. Here the word true won't be occur. Here the word true won't be there. As in the real expansion, the word true alone will be missing. See, is defined as the ratio of the apparent rise in the volume of liquid per degree rise in temperature. Is defined as the ratio of true rise in volume of a. Here the true volume, here the apparent rise in volume. True rise in volume, apparent rise in value. This alone the difference between coefficient of expansion and coefficient of apparent expansion. Okay, then see the experiment. Measure the real and apparent expansion. With the diagram, I will be explaining this. You are filling the round bottom flask with a certain volume of a liquid and marking the level of the liquid, closing the mouth of the bottle with the one hole rubber cork and putting a capillary tube. Then started heating the round bottom flask. As soon as you heat, the level of the water will be reduced to L2. First marking is L1, the second marking is L2. It is reduced to L2 because first, as soon as you are heating, the heat won't be transferred to the liquid, but it will make the container to be expand. So the level of water is reduced. Then on continuous heating or the further heating, the heat transferred to the liquid and the liquid started expansion. The level of the liquid rises to the level L3. The level of the liquid rises to the level L3. The difference between L3 and L2 is real expansion. The difference between L1 and L3 is the apparent expansion. Are you able to understand both? Just you are taking a round bottom flask, filling with liquid at a certain level, closing the mouth of the flask using one hole rubber cork and fitting the capillary tube on the one hole rubber cork. Heating the round bottom flask, first the container will be expand, so the liquid level reduced to L2. On further heating, the heat transferred to the liquid and the liquid started expanding. Now the raised level is L3. The first level is L1, reduced level is L2, increased level is L3. The difference between reduced level L2 and increased level L3 is a real expansion, and the difference between first marked level and the increased level is an apparent expansion. These two questions are important 5 marks in this lesson. Have you understood? Coefficient of real expansion, coefficient of apparent expansion, and measure of real and apparent expansion. Okay, up to this today's portion is over.